Okay, so welcome back. Now, in this example, we're going to find the area of a curve, of a polar curve. So this is the equation that we've seen before. So r equals 3 times sine 2 theta, and here's the graph of the equation. And what we want to do is we want to find the area of the first petal, okay? Now, because of the symmetry, if we find the area of the first petal, the area of all the other petals are the same, incidentally, okay? But let's think about this for a moment. Okay, so again, as we trace out the first petal, what happens? It comes from here and goes out, and then it comes right back in. So when is the radius 0? Okay, well, we know that r is equal to this, so we want to know, hey, when is this thing equal to 0? Because we know it starts at 0, and then it comes through and ends at 0. So we can do that by just setting this equal to 0 and asking ourselves, okay, so here, so we could say 3 sine 2 theta is equal to 0, right? We can divide both sides by 3, so that again just gives us sine 2 theta is equal to 0. Okay, so so here's where our knowledge of trig functions comes in. So when is sine equal to 0? Well, sine is equal to 0 for any multiple of pi, any integer multiple of pi. Okay? Well, here we have 2 theta. So we need to know when this is equal to some multiple of theta. So in other words, 2 theta, so sine 2 theta is equal to 0 when 2 theta is equal to any multiple of pi, integer multiple of pi. Which means that means when theta is equal to any multiple of pi over 2. So when n is 0, this is 0, so when theta is 0, it's 0. And also when theta is what? 1 pi over 2. So that gives us the first trace. So at 0, it's when theta is 0, r is 0. But then as we trace out, the next time it comes back to 0 is at pi over 2. So that gives us the first the tracing of the first petal. Okay, so now that we understand that, why did we do that? Well, because we need to figure out the limits of integration. Okay, so now that we know that, let's set up our equation, or our integral. So we know that the area is going to equal the integral from 0 to pi over 2. Okay, that's what we just figured out. And now what is this equal to? Well, it's 1/2 times f of theta squared d theta. And so of course the 1/2 can come out, right? So we can bring the 1/2 out. Okay, and so now what's f of theta? Well, f of theta is r, right? It's just r squared, right? So it's f of theta squared. So this is f of theta. So this is going to be 1/2 the integral from 0 to pi over 2 of 3 sine 2 theta quantity squared d theta. So if we want to put this in square brackets, we can do that too. Okay. So now we're going to just use the property of exponents and simplify this. So what do we get? We get this is equal to 1/2 the integral from 0 to pi over 2 of 9 sine squared 2 theta d theta, okay? And then of course we can pull the 9 out. So let's come back up here. I'm going to erase this. And so now we're going to come up to here, and this is going to be equal 9/2 the integral from 0 to pi over 2 of sine squared 2 theta d theta. Now, here, this is where you got to remember our previous topics, right? Our previous videos that I did when we were dealing with the reduction, right? Dealing with powers of sine and cosine. So, in this case here, we cannot shave off, right? We can't use the Pythagorean identity because all we're going to get is everything in cosine. That's not going to help us. We can't shave off a sine because, again, that gives us a product that we can't do anything with. So we're going to have to use the half angle, okay? So remember sine squared theta, okay? So what we're going to use is we have sine squared theta is equal to 1/2 1 minus cosine 2 theta. So that's the identity that we're going to need to use. Okay? So now what I'm going to do is I'm going to replace this with this. So again, but instead of theta, I have 2 theta. Okay? So what we're going to do is this is going to become 9/2 the integral from 0 to 2 pi, and this is going to become 1/2 times 1 minus cosine what? 4 theta. Again, we could use square brackets, d theta. And so now, guess what? Now we can integrate this thing. Okay? So we can integrate this thing term by term. Okay? So let's do that. So again, I'm going to pull the 1/2 out. So this is going to become 9/4 the integral from 0 to pi over 2. And this just becomes 1 minus cosine 4 theta d theta. And now I'm just going to integrate term by term. So this is going to be 9/4 times, well, the integration of 1 is just going to give theta, right? Because again, we're in terms of theta, so this is just going to give me theta. And then the integral of cosine. Okay, so now, here, the antiderivative of cosine is sine, right? So I'm going to have sine here. So it's going to be sine of 4 theta. Now, but remember, this is a function within a function. So I have to use the chain rule for integration, which means I have to integrate the outside function and divide by the integral, excuse me, the derivative of the inside function. So the derivative of this is 4, right? The inside function is 4 theta. So the derivative of 4 theta is 4. So I have to divide by 4. So I get 1/4. And again, if you ever want to check, it doesn't hurt to go ahead and take the derivative of this, right? So if this is the antiderivative, then the derivative should give you back to what you started with. So again, if I take the derivative of the outside function, that gives me cosine 4 theta, and then multiply by the derivative of the inside, which is 4, I get 1, and I get right back to where I started with. So that works. Oh, I don't need this. Yeah. So then this is evaluated from 0 to pi over 2. Okay, so now we're pretty much at the end. So let's finish this up and see what the area becomes. So now I'm going to evaluate at pi over 2 and then evaluate it at 0. Well, in this case, at 0, this whole thing is 0 and this whole thing is 0. So I don't have to worry about the 0. But I can evaluate this at pi over 2. Okay, now, at pi over 2, this 4 theta becomes 2 pi. Well, what's the sine of 2 pi? 0. So guess what? This becomes 9/4 times pi over 2, okay? Which equals what? 9 pi over 8. And that is the exact rule. So the area that I get is 9 pi over 8 square units. Okay, so that's it. We'll come back and I'll do another one. Take care.